Hello everyone. So, am I audible?
Yes, sir.
Hello. Okay. So we'll be starting with this week's content, week 5. Last week I was solving this question regarding the SPM, I guess. Yeah. So it was I was thinking like it was not. It didn't give us the correct options, but turns out that we forgot to cancel one term here. That's why it didn't quite happened. So I'll just try to redo that. So the question number 7 from last class. So we have this optimization problem with us here. So people are still joining, but yeah, since this was the question from the last class, I'll just discuss it as it is. Yeah. So this is our optimization objective, and this is your constraint. And when there is there are like constraints that difficult to do, we apply the Lagrangian, and we found the Lagrangian as this one. So this Lagrangian is already been found, and we sort of derived it here. Where is it? Yeah, here. So we found it here. So option C was correct. Next thing was to like check if the Lagrangian holds strong duality or not. So to do that, we had to do the dou. So we had to. So this is the Lagrangian, and we had to do this dou L by dou lambda, and so this is the G of lambda and dual problem. We have to find the DL by dou lambda and maximize it, and put the results in the equation, and if it satisfies, then it is strong duality. So let me write the G lambda. G lambda was equals to, sorry, I have to go back and forth again. 1 plus lambda x square minus 6 lambda x. 1 plus lambda x square minus 6 lambda x plus x square minus 6 lambda x plus 1 plus 8 lambda plus 1 plus 8 lambda. So when we do G lambda by to lambda, it will be Yeah, so it will be with respect to lambda, it will be constant. So first term will be 0. Then it will be x square minus 6 lambda plus 0 plus 8 will be equal to x square minus 6 lambda plus 8. If we put that to 0, x square plus 8 equals to 6 lambda. Lambda equals to x square plus 8 by 6. Right. Yeah, so that's d lambda by d lambda d dou g by dou lambda, and also we need to find dou g by dou x. That will be equal to 2x 1 plus lambda minus 6 lambda and rest 0 implies x equals to, that will be 2x 1 plus lambda will be equal to 6 lambda if we equal this to 0, and x will be equals to 6 lambda by 1 plus lambda into 2 with the lambda by 1 plus lambda, the value of x. So how to do is that we'll just put this in the equation, and the equation was x lambda was 1 plus lambda x square minus 6 lambda x plus 1 plus 8 lambda, and we'll put this value in place of x. It will be 1 plus lambda 9 lambda square by 1 plus lambda square minus 6 lambda into x is 3 lambda by 1 plus lambda plus 1 plus 8 lambda, and we cancel this. We forgot to cancel this last time, so that will be 9 lambda square by 1 plus lambda minus 18 lambda square by 1 plus lambda plus 1 plus 8 lambda, and then we can cancel this. It will be minus 9 lambda square by 1 plus lambda plus 1 plus 8 lambda. So this will be your g, like this will be the g of lambda. Sorry, this is not g of lambda, just L of lambda, L. So what you do is that you take the Lagrangian form, then you differentiate it with respect to x. No, do this x and equal it to 0. The value that you'll get, you'll put it back in the equation. So earlier, like you're trying to solve this 2 variable equation. Now it is 1 variable equation, and this is called the g of lambda, and this will not be defined for lambda less than equals to 1 minus 1. Hence, okay, so if you solve this, the minimum will be at lambda equals to 2 and x equals to 2. Okay. So since these 2 points stay inside the convex set, so we can say that this is a strong duality, strong duality. But anyway, so that's just the condition. but one thing that I was not clear was that we are not able to get this outcome last time. I'm not sure why, but so I think I was not canceling these things out. That's why. But we got this, and after that, you can check the condition for strong duality. If the condition for strong duality is holding, then it is strong dual, else it is not. Then we'll move to the next week's questions, and we'll start working on that. Try reading the first question, and I'll discuss that in a while. Let me open. Question number 1. Question number 1 says, consider a feed-forward neural network that performs a regression on a p-dimensional input to produce a scalar output. It has m hidden layers, and each of these layers has k hidden units. What is the total number of trainable parameters in this network? Ignore the bias terms. So if you have answers, you can post it in the chat. Otherwise, I'll discuss it. Okay. So from this week onwards, we'll be dealing with uh, more like deep learning stuff. So I think you will be comfortable on machine learning. So what it is saying there is a feed forward neural network and there is a feed dimensional input. So let's say build just, so this is, let's say, p units. Okay, and there are m hidden layers. Okay, so there are like layer 1, layer 2, layer 3, like that. Okay, m hidden layers, and each layer has k hidden units. So this belongs to the pair k. Okay, what is the total? So and consider feed forward neural network that performs regression on p-dimensional input to produce a scalar output. That means the output layer has one layer. Okay, one unit. It has m hidden layers. The m hidden layers, lm. Let's write lm, and each layer has k hidden units. So there are k hidden units in between. What is the total number of trainable parameters in the network? Ignores the bias term. So as you know, so as the total number of trainable parameters between these layers, this layer and this layer. So there will be weights, right? So the dimension of this matrix, weight matrix, would be k into p. Okay, and dimension of this would be k into 1. Okay, apart from that, here there will be k into k. Here there will be k into k. That means for 3 layer, we have 2 pair of this. If there is m layer, there will be m minus 1 pair of k into k. Okay, till this point. Okay. So if you connect all these things, you'll get, so if you connect all these things, so from this you'll have kp plus, from this you will have m minus 1 into k square plus, from this you'll have k. This will be the trainable parameters. We're not considering the biases because it is saying that ignore the bias terms. Okay. Hence, this will be the answer. So that gives us the option number, this one. Answer. Did everyone get this one? Oh, on the chart. 1 equal to C. Yeah, perfect. Does anyone have any doubt in this question? No doubts? Okay. So we'll move on to the next question. I hope everyone is understanding this one. So they are like very simple ones, deep learning questions. We'll move to the next one. Next question. You can try reading the question and we'll solve it in a while. Two equals to B. We'll see. So there is like input units. The number of input unit is uh, P. So this belongs to P dimensional input, and there is Y. Y belongs to T dimension. Okay. So there are weights here. So weight equals to D cross P. Okay. So everything is like ReLU. ReLU Z equals to max of 0 and Z. So if we find dou yi by dou wij, I can write y equals to ReLU w times x, right? W is D cross P and x is P cross 1. Hence, the y would be D cross 1. Okay. So let's just write this in a detailed. So if you write y, so y can be written as y1, y2 up to yd, right? That will be equals to, it's a element wise value. That means it will be equals to xi wi, no, it will be, sorry, I'm multiplying d cross p with p cross 1. So w will be w 1 1, w 1 2 up to w, number of column is p, right? 1 p. Similarly, w 1 up to w d1 is w dp. Okay, and the this will be x. So x2 xp. Okay. That will be equals to w11 times x11 plus w12 times x2 up to plus w1p times xp. So this is the way in the last line it will start to behave. Okay, so if we equate this, so y1 here would be equivalent to this one. Similarly, yi would be equals to w to it wi, wi I1 times x1 plus wi2 times x2 up to wip times xp. So if we do dou yi by dou wij, it will be equals to, so if you see this dou ij, so dou ij would be like only one term would be there and the rest. Okay, so all these things I'm putting ReLU here. So So ReLU on top. So this all can be written as summation of j equals to 1 to p summation of j equals to 1 to p, okay, and w ij, okay, w ij x j, because j is varying, so 1 1 2 2, so replace with j, okay. And since we are putting ReLU, what I'll do is that I'll just put a ReLU function on all these things. ReLU function is max of this value and 0, okay. So this is our entire thing what we're trying to solve, okay. Then summation of j equals to 1 to p, so wij xj, so these are term of interest, right? wij xj, if this is less than 0, less than equals to 0, that implies less than equal to that, then implies, so okay, so when we have a function that is, so these are function of interest, right? These are function of interest. So when you have a function of interest where the function is not continuous, so not differentiable, it's piecewise difference. That means if you plot this, if you plot ReLU, it will be like, yes. Okay. So if you plot ReLU, it will be like this. Okay. That means it's not differentiable here, like, because all the value less than x, it should be 0. All the value greater than x, it should be x. So what we need to do is that we need to differentiate this value and this value separately. So we have our final expression as this. So now we are looking at this part where the value of this is less than 0. So if it is less than 0, that implies my yi would be 0. Right? My yi would be 0. That implies my dyi by dwij would be equals to 0. Okay. If my summation of j equals to 1 to p wij xj is greater than 0, so then my yi is equals to the same thing as this. Summation of j equals to 1 to p wij xj. Okay, that implies dou yi by dou wij would be equals to so there will be only one term corresponding to this, others will be 0, it will be xj. Okay, so if I have to combine this equation to write that, the correct way to write that is using this notation, that I yi greater than 0 xj. That means when is an identity, is that term in the following option, I is an indicator function that returns once if the condition is true and 0 if it is false. So if this is true, the value of this would be 1, and 1 times x equals to x, which is this. If it is false, now that means this one. The value of this would be 0. X times 0 equal to 0. So combining these two terms and like writing it one sentence is like this: I greater than 0, x. Okay, so that will give us option B as the correct answer. Here, option C is the correct answer. Okay, moving on to the next question. Read the question, and I'll try. I'll hope that you guys try to solve it. Some people are giving answers as B and C, so that's good. But try solving it and giving the answer like with some explanation, like or some steps that you did.
So,
Yes.
how do I write down equation for WA and WB? Sorry, in third question.
How do I? The third question. What?
Yes, sir.
How do you? W and W are arbitrary weights. How do you write equation?
Yes, sir.
So you don't need to write the equation for this. It's just saying that these are weights, random weights. Just assume that it's just W.
Sure, fine. Sir, with what parameters do we find del, sir, here in this third question?
Wait. Let me see. Yes. Yeah. What were you telling?
Sir, with
Repeat.
respect to what parameters do we find del, sir, in this question?
What parameters you find del? No,
Yes,
it is
sir. Del.
asking that you're asking that you have to choose another correct answer. So delta of y subscript h means we are finding the derivative of y with respect to h, but since they are like vectors, so it is denoted as gradients. I'm not sure like what's the question I'm asking. So we don't need to estimate the parameters. But it is saying that there is a neural network where so let's just put it in the figure. Okay, so there is x. Okay, there is some x, and then there is layer A, and there is some layer B, and there is some output y. Okay, and this is your W A, WB. Sorry, this is not output. So layer B is the output, I guess. Yeah, so weight A getting hidden layer A, weight B getting hidden layer B, and B is the output. So your Y equals to, so X into WA activation, then you pass this into WB activation. This is your Y. Okay, so these two are used, and your this is saying that it is H. That implies Y equals to sigma H WB. Okay. So he's saying that this is a network. Okay, and Y equals to this, and W and W are arbitrary words. So which of the following statements is that true? And this is like gradient of F with respect to Z. Okay, so if we take gradient of Y with respect to H with this equation, we can say that, okay, sorry. So this is your this is your sigma. Okay, so this entire thing is H. So you can replace this as H. Okay, so it's saying that first is gradient of Y with respect to H. Okay, that is simply equivalent to dou Y by dou H. But since it is vector, so you have to write the gradient. Okay, so Y equals to sigma Y WB, right? Sorry, not Y. Y equals to sigma H, because we replace with H, WB, right? So if we take gradient of Y with respect to H, it will be equals to, so okay, so we will be needing WB, because this will be gradient of sigma H WB with respect to H, and that will be equals to, so that will be, so this will be equivalent to, let's say, dou sigma H WB by dou H. Since we are differentiating with respect to H, we only need WB. We don't need WA. So hence option A would be wrong. Similarly, if we find WI by WA, okay, now we can say dou Y by dou WA, and here we have to use this equation, dou sigma X WA into WB by dou WA. So if we do this, we need WB to find this with respect to WA. So hence WB is it is dependent on WB. So option 2 would be correct. Similarly, dou H by dou WA. So dou H by dou WA will not. So it will give it will depend on X. So it will not depend on WB. Hence this will be incorrect. And similarly, the fourth option, dou Y by dou WB depends on WA. Yes, because Y is this. If you find dou Y by dou WB, so this will be dependent on WA because WA is in the equation. So option D will be correct. So you have to like find the gradient with respect to so this is your Y and this is your H. So you just have to write dy by dx. I mean, what is the whatever the with respect to is, and or d h by d whatever the vector this is. So then we will find that if it is dependent on this or not. That will clear some of the doubts. Try doing that again. So we'll be getting the correct output.
Sir, with respect to that H and with respect to Y, can you please show that once more? The third and fourth option.
Okay. So my H is sigma WAX, right? So if I write, so it's not exactly correct because it should be written delta, but I'm just for understanding writing dou H by dou WA. Okay, and it will be dou sigma WAX by dou WA. So if it is, let's say this is linear, this identity I. Okay, let's say this is identity, then my this is dependent only X. Right? If I differentiate this, and if it is, let's say if it is identity, the answer would be X. So it doesn't depend on WB, right? So that's what it is saying. After calculating this, what does this depend on? It will depend on only X. The value of this will depend on value only X, not the WB. Similarly, my Y was sigma WAX WB. Okay, this is my Y, and if I do dou Y by dou WB, then this. So let's say this is identity. So when I am saying that sigma is identity, so it is say it will go here. It's not written, but sigma is mostly the activation function. It would be some non-linearity, but since let's say just as that it is identity, identity means sigma of x equal to x, same function. Okay, if it is identity, then it would be WAX into WB. Okay, dy by dB equals to d by dWB. So if I differentiate this, it will be WAX. That means this operation is dependent on WA and X. It is saying not only like just depends on WA. So this statement will be correct. Just assume the activation function as 1 or identity and move forward, and you will find the relationship between if there is a relationship between the one that is asking and the one with whose respect we are taking the gradient. Okay. Next question is question number 4. Which of the following statement about the initialization of neural network is true? So this is very easy question. I'll not be doing that much. So you try thinking. So the first option is two different initialization of the same network could converge to different minima. What do you reckon? Like, okay, there is chat. 3 is B and D. How can you explain? Okay, so this is done, right? 3 is done. Bharti is telling answers. Nice. Okay, 4 is so option 1 is two different initialization of the same network could converge to different minima. Okay, so I'll just I know like you shouldn't be spending much time on these questions, but since there are a lot of people joining who are very beginner, I'll try to do as much as possible. Okay. So so this statement is true. Let me show you how. So let's say there is a neural network with just weight W, one weight. Okay. So there is weight, and let's say this is the loss. Okay. And let's say so this neural network is like this: your X, W, Y. Okay, that's it. Input is X, X time W. You add some bias, doesn't require, it is equal to Y. It is like this. Okay. So let's say, and if this is predicted Y and Y minus Y square, square, what is your MSC? No, sorry. Let's just write it very simple. This is your Y hat, and let's say your loss equals to loss of Y and Y hat, where Y is your actual level. Okay. Let's say I plotted the loss curve in this like this. Okay. And everyone know about the gradient descent algorithm. So this, let's say there are two different initializations on the same network could converge to different minima. Let's say one time you initialize your network here, and second time you initialize the network as here. Like it is to W0 initial weight, W01, and this here W02. So if you initialize it in this way, this will converge to here, and this will converge to here. Okay, this will be your W optimal 1, and this will be your W optimal 2. Okay. So even if they are the same network, very simple network, they all both converge to different points. Hence option 1 would be true. Okay. Then the next option is given for a given initialization. So that means, let's say these are loss curve, right? It is saying for a given initialization, like for a given initialization like this. Let's say we have two learning rate. Learning rate 1, let's just write lambda. Lambda 1, lambda 2. It is saying that for a given initialization, W0 on two different uh, uh, learning rate, not saying until the gradient descent will converge to the same minima irrespective of the learning rate. So let's just take two learning rate, lambda 1 and lambda 2. Okay. And irrespective of the irrespective of the value of the learning rate, it should converge to the same minima. So let's say the learning rate 1 is very small. What will happen is that it will come down to this minima. If this is very large, so it might suit the minima. Okay, and come down here. Okay, so they might end up in two different places. So since it is saying that it will converge to the same minima, it is wrong. So that's why option B is wrong. Any doubt in these two options so far? Let me know in the chat. Or you can speak up. DAB. DAB is wrong. A and D. A, B false equals A and D. Nope. Okay. So B is wrong. Third is the weight should be initialized to a constant value. This is wrong. So there is no explanation for this. The initial value of weight should be sampled from a probability distribution. Yes. So this should be true. I think this is a theoretical thing, and there's no need to explain this. Okay. Next is question 5. Question. Okay, let me drag this down. Okay. Yeah. Question number 5 is there. Try solving that. Then goes the question number 6. Question 7. Question. Consider the following statement about the derivative of the sigmoid. This and tan h. Activation function. Which of the following statement is are true? So you just have to find the derivative of the sigmoid and tan h. Then you have to find this. Okay, so let's solve this. It's easy. It looks scary, but it's easy. So your sigmoid is this. So the derivative of sigmoid, as you know, is sigma of x 1 minus sigma of x, right? So this is your derivative of your sigmoid. If x tends to minus infinity, okay, if x tends to minus infinity, then sigma of x will tend to what? So let's take option number B. Okay, so if x tends to minus infinity, sigma of x will tend to. So we need to find limit when x tends to minus infinity. What is the value of this sigma dash x? We know the sigma dash x is this. Okay, so we are finding x tends to minus infinity. This will equal to when what is the value of this when x tends to infinity minus infinity. If we put the value here, we'll have 1 by 1 plus e to the power minus plus infinity. Okay, e to the power infinity will be equals to infinity, right? And 1 plus infinity will be equals to infinity. So 1 by infinity equals 0. Okay, so hence this will tend to here 0. That implies 1 minus sigma of x will tend to 1. Okay, that implies sigma of x into 1 minus sigma of x, this will tend to 0, this will tend to 1. So together they will tend to 0. Okay, that implies limit x tends to minus infinity, sigma dash of x will be equals to 0. Option B is correct. see someone has answered already. B and C, B and D, C. B is correct. Okay. Then C, then we'll see other options. Okay. So question number, so next is, I'll just solve the solution because we don't have much time. Tan H dash X is equals to 1 minus tan Hx square. As you know, tan H varies between -1 to 1. Okay. If tan H varies between -1 to 1, its square will vary between 0 to 1. Why? All the number from 0 to 1 will have square between 0 to 1. All the number negative of 0 to 1 will also have square between 0 to 1. Hence, in total, it will be between 0 to 1. So if it varies between 0 to 1, this entire thing will vary between, if it is 0, value will be 1. If it is 1, value will be 0. That means it will also vary between 0 to 1. Hence, tan of h of x will vary between 0 to 1. Okay, so option C will be correct. And if you calculate option D, it will be wrong. You know why? If it is, because like if it tends, then if x tends to plus infinity, this will put x as plus infinity here, and this will be tan h x plus infinity here. And if we put plus infinity here, it will be infinity minus 0, infinity plus 0. It will be infinity by infinity, not defined. It will not tend to 1. Okay. Similarly, also this is not correct. You can cross it. We'll move to the next question. A geometric distribution is defined by probability mass function f of x given p equals to a geometric distribution is 1 minus p to the power x minus 1 p for x equals to 1 to up to infinity. Given samples 4, 5, 6, 4, 3 drawn from the distribution, find the maximum likelihood estimation of p. Using this estimate, find the probability of sampling x greater than or equals to 5 from the distribution. So this is a distribution. Okay. So you have to first find the likelihood of the function. Then you have to find the log likelihood of the function. Then take the derivative of the RHS with respect to p and write, and then equal to 0. Then you simplify it, and then you will substitute the value, and then you will find the x greater than or equals to 5. This is a very long question. And question number 8 is about the Bernoulli distribution. I think we'll skip it. Question number 7. Question number 8 is, which of the following statement about parameter estimation technique are true? Okay, so let's just solve the question number 8 first. Then we'll go back to question number 6 and solve that, and we'll leave the question number 7. This is just about beta distribution and all. I don't think it is broadly covered. We'll solve question number 8 first. Then we'll go to question number 6. Sorry. Um, A and D, B and D, C. So, the correct answer is A and B. Um, it's saying to obtain a distribution over the parameter over the predicted values of a new data point. Distribution over the predicted value of a new data point. We need to compute an integral over the parameter space. So option A is true, and option D is also true, because yeah, it's a similar function with a similar thing. We need a point estimate of the parameter to compute the distribution of the predicted values for a new data point. So if you go to the video of parameter estimation 3, at around 1 to 2 minutes, we'll find an equation. Based on this equation, like I think A and D would be correct. But intuitively, if you say you have to compute the integral, I don't recall the exact equation, but so let's say you have some point estimates, and you have to calculate the distribution these points follow. You have to integrate it over the parameter space to get it. Okay. And option D will also be correct, because we need point estimate of the parameter to compute a distribution of the predicted values for a data point. Apart from that, B and C, the map estimate of the parameter gives a point prediction for a data point. The maximum likelihood estimation of a parameter gives a distribution of predicted values for a data point is false, because both map and MLE give the point estimate for the parameter, leading to a prediction on the new data point. Okay. Oh, okay. So that means sorry, yeah. So map estimation gives the a point prediction for new data point, that gives the point estimation, but the maximum likelihood of an parameter do not give the point estimation. It gives yeah. So MLE also gives the yeah. So MLE also gives the point point estimation of the or point prediction of a data point. It is saying that it gives a distribution of the predicted values, which is not true. So hence this will be false and this will be true, and this is true and this is false. So these are actually contradicting statements. I don't know how I read it incorrectly. To obtain a distribution over a predicted value, we need this data point, we need to compute the integral over the parameter space. We need a point estimate of the parameters to compute a distribution of the predicted values for a new data point. Okay, so this is false and this is true. How did you get B? The answer is A and B. Not B and D. Yeah, so map estimate is basically like P of X given theta. Sorry, theta given X. And this gives the point estimate. So find me a parameter which will maximize my X. We'll solve the last question for today, like the sixth question. Question is a geometric distribution is defined by this. Let me just adjust this thing. Geometric distribution is given by this. This is a typical geometric distribution for X equals to 1 to infinity. Given samples this. Okay. Find the maximum likelihood estimation of P. Maximum likelihood estimation of P. So as you know, the likelihood function L, find the MLE of maximum likelihood of P. So likelihood function of P given x1, x2 up to xn is equals to pi I equals to 1 to n 1 minus P 1 minus xi P of xi. Okay. It is equivalent to writing P of n times 1 minus P summation of xi minus n. This is a bit confusing, I know, but these two equations are the same. I'll tell you how. So this means that you just need to take and multiply it one after another. So it is like for I equals to 1, it will be 1 minus P 1 minus 1 P of sorry P of x1 P of x1 then times 1 minus P 1 minus x2 P of x2 times till 1 minus P 1 minus xn P of xn. Okay, and if you multiply all these things, you can separate out P of x1 times P of x2 up to P of xn times 1 minus P into 1 minus x1 1 minus P into 1 minus x2 1 minus P into 1 minus xn. Okay. So if you add all these things, so it will be P x1 plus x2 up to xn, it will be 1 minus P. So 1 minus x1 plus 1 minus x2 plus up to 1 minus xn. Okay, and P x1 plus xn 1 minus P, all the ones will come up to 1 n minus xn xn. Oh, sorry. This is x minus 1, right? X minus 1. We wrote it 1 minus x. So this will be here. You can change it to minus n here. Okay. Okay. So this will lead to P of n 1 minus P summation of xi minus n. Okay. This is likelihood function. The log likelihood is just take log of likelihood function P x P given x1 x2 up to xn equals to put log in here. You put log and multiplication, it will be addition, and this will come out. So n log P plus summation of xi minus n into log 1 minus P. This is the log likelihood. Okay. This is their log likelihood. Log likelihood. Find the maximum log likelihood of P using this estimate. So a distribution, from a distribution, you have to first calculate the likelihood, then you take the log likelihood, then you find the maximum log likelihood. For maximum log likelihood, what you can do is that you can maximize this. So you can find the maximum log likelihood. Okay. So how to find the how to maximize one thing? You have to take the derivative and equal it to 0. So when you take the derivative and equal this to 0, it is getting lengthier. So I'll just write the final equation that is already solved. That I already solved it. So if you take the derivative of this with respect to P, this will be n log P will be P by 1 minus P. And similarly, this would be as it is. And then this would like also like 1 minus P by 1 minus 1 minus P. And it will cancel out to be like just P. Okay. And if you just find the final parameter, P maximum likelihood will be equals to n by summation of xi. This is after taking derivative of this and equating to 0. Okay. So if you substitute the value of this, okay. So if substitute, so what is the, so it is saying that this is the parameter at which so sorry, this is the p where like the value is maximum. Okay. If you just put the values of our x here, x and n. So what is our n? N is the number of elements that we have in the distribution, right? So how much the number of elements that we have? If you count, here we have 1, 2, 3, 4, 5, 6 number of elements. So 6 by summation of xi, that is 4, 5, 6, 5, 4, 3. 4, 5, 6, 5, 4, 3. 6 by, add all these things. 4, 3, 7, 5, 5, 10, 4, 6, 10, 27. And this will come out as 6, 2, 0 .62, 0 0.22. So it will be 0.22. Okay. And so we have to find p of x greater than or equal to 5. Did someone write anything? No. So if we find p x greater than or equal to 5, there will be I equals to 5 to plus infinity 1 minus p I minus 1 p is equals to 1 minus p4. Why p4? Because we have 4 values that is greater than or equal to 5. 1, 2, 3. Oh no, it is 3. Oh, sorry. So it's this. So I is starting from 5, right? It is 5 minus 1. 4. And if we substitute the value of p m and here p x greater than 5 equals to 1 minus p 0.22 equals to 0.22 0.78 to the power 4. First 0.3701. So I think D would be correct answer for the value 0.366. Yeah, so if we just look at the steps, first is like we found the likelihood equation. From the likelihood equation, we found the log likelihood equation, and we maximize the log likelihood equation by taking the derivative of u and we say equating it to 0. And on simplifying, we got the optimal parameter is like p is n by summation of xi. Okay. Then we substitute the value of all these x and n to get our p ml, like that's the maximum value. And so then we have to find the probability of x greater than or equal to 5. Just put all those values and we got the output as answer. Someone said B, right? It should be D. So yeah, so this is everything for today. Hopefully we'll meet next week and we'll solve some more questions from
Sir,
week
please,
6.
can you tell me how we got 60 divided by 60, sir?
Oh no, not 60. It's just okay. So it's not 60. It's just 6 by 27. What I did is that I
6 by
put a 0.
27. Okay.
It's not 60. 6 by 27.
Okay.
Okay. Thank you. I'll close the meeting. And I hope everyone has the link to the channel and they'll get the solution from there. Thank you.
So for this answer is 0.3701, no, sir?
Yes.
But
So,
here it is not the option.
It's 0.366 is also fine.
Oh, okay. Round figure we can. Okay.
Yes.
Okay.
Thank you.